Hello everybody and welcome to this tutorial. Today I will be talking about Nmap and how you can analyze its traffic with Wireshark. So Nmap is a tool for scanning network. You use it to scan networks basically. It can give you a great deal of useful information. For example, if you're in LAN, it can give you MAC addresses of the machines that are within LAN, provided of course that you know the IP addresses. But even if you don't know the IP addresses, you can just scan the entire subnet or something of a kind. It can also determine which operating systems are running on remote machines, whether they are in LAN or outside. It doesn't matter. It will conduct a scan, but primarily it can tell you what ports are opened on the system. And if it tells you what ports are opened on the system, you can conclude a great deal of things from that. For example, you can figure out which services are running, and you can assume which operating system is running there because you have some default open ports on some systems, and in such a way you can get more information. Now, you shouldn't scan a system that you do not own or have an explicit permission to scan, because that is not permitted. However, today, within my lab environment, I will be scanning my own virtual machine, and I will show you how you can actually how you can monitor the traffic, and monitor, more importantly, how you can monitor the size of the traffic. Because the less packets you have, the lower the probability is that your scan will be detected, and you have a lower chance that the firewall will actually stop your scan as well. Now, this is very important for people who are into penetration testing. They tend to use this method, basically just scan a virtual machine with Nmap and then have Wireshark monitor the scan, and in such a way see which parameters, which sort of scan of Nmap will generate the least amount of traffic. In any case, as I've said before, people in pen testing who do this, they have a permission to scan the systems and to perform these kind of tasks. So unless you own the system or have a permission to scan the system, do not do it, as it is not permitted. Anyway, what you will need for this tutorial is Nmap installed on your system. On Linux, it's pretty much easy. There isn't that much science. There isn't really that much thinking to it, so to say. As you can see, I've just typed in. Oops. I've just typed in here yum search nmap. This -c option is basically just tells my packet manager yum, do not perform updates at this time. Just try to find nmap. Just try to find package nmap. You don't need to worry about that. And as soon as you type that, you get a output down here. So I don't know, you have some sort of things here which you're not really that interested in. This is also a very interesting tool. It says Nmap's NCAT replacement, but nothing is ever going to replace NCAT. I mean, seriously, like, that's one of the tools that has been around for quite a while. And if you don't know what it is, I strongly advise that you get familiar with it. That is one small task that I have for you if you wish to learn more about networking, monitoring networks, and troubleshooting them. Netcat is a fantastic tool. It allows you to connect on pretty much any port in any way. It supports a great deal of protocols, and it is fantastic for testing. It's completely free. You don't need to pay for anything for it. It's open source. So yeah, I'm not selling anything or anything of a kind. Just have a look at it. It's gonna be, if you plan to do something with networks or have a career, you're definitely gonna need that tool. Anyway, coming back to the subject, down below you have nmap.x86_64. It says network exploration tool and security scanner. Basically, that is precisely what it is. As I said, it just scans the networks and it gives you a lot of information. If you wish to install it, just type in yum install and then nmap, nmap, and there you go. That should do it. You will install whatever you need to. That will install the package without any problems. As you can see, I've pressed tab with a wrong argument and it has given me some rather weird options, but irrelevant. You just type in yum install space nmap and it's gonna run through. If you just go ahead and clear the screen. Now I do have my virtual machine set up here, one of them anyway. It's just a different edition of Fedora, the next one, 21, where I'm testing it. This is a live boot, not an actual installation. That's why it's running a bit slower. So its IP address is 192.168.1.4. And that is the IP address which I wish to scan and monitor the traffic. So let me just go ahead and start a live capture on my wired interface P8P1. Apply my filter here. So you should know this filter by now. Apply. There we go. So there isn't any traffic now. I mean, there is traffic, but nothing is really being displayed because I have told it that the source IP address has to be me. Basically, this is the IP address of the machine that I'm using at the moment. And the destination IP address has to be the virtual machine, which is this is the IP address of the virtual machine that you've seen a moment ago. So as you can see, there is no traffic now, nothing of a kind. Down below, you have packets, the amount of packets, it says packets 21, and displayed 0. Excellent, that is precisely what we want. Now we can conduct our scan. So let's begin with the basic fundamental Nmap scan. I'm just going to go ahead and type Nmap and type in the IP address. So 192.168.1.4. And remember, to pass the option double V. So not W, but double V. You can also say 1 or 2. Basically, this defines the verbose output. How much information do you want the program to give you in regard to what it is doing at the moment? And I always like to be informed, so I always pass the double V here. It is quite in handy. It's quite in handy because I don't know, sometimes Nmap scans will take a while and you will just see a blank screen, you won't see anything happening, there will be no progression bar or anything of a kind, and you will think, oh, it's bugged or something of a kind, and you will interrupt the scan, and then you will need to do the whole thing all over again. Like this, you can see what it is telling you. There we go. It says starting Nmap, initializing rping scan, scanning 192.168.1.4. And it's clearly telling you what it is doing. There we go. The traffic is now being generated, and we have a lot of things here that are going back and forth. And there you go. The scan is finished. This is a very fast scan, obviously, because this is all in LAN, so the scans can be conducted rather fast. But look at down here where it says packets displayed. It's the the middle of the screen in the bottom. It says that I have 1500 packets approximately, and that my Nmap scan has consumed 1220 packets. That is a huge amount. I mean, this is bound to be detected for sure. If there is a network admin on the other side, they will notice this scan, no problem. So we need to actually work on reducing the size of our Nmap scan. One of the first things that I'm going to do, aside from clearing my screen and making a more neat working environment, is go ahead and type in nmap --help. Press enter, and this is gonna prompt a help bar. Let me just expand this a little bit for you so you have a better overview, and repeat the process because terminal does not resize the text by default. And so here we have some other options in the example. It says these are just miscellaneous arguments for Wireshark itself, but we have a ton load of other options. One of the most, look at how many of them there are. Pretty much the same procedure as with T-Shark. You type in help and you figure out what is where. So this is one of the options that people would use on more frequent basis. So -O. So let's try -O and let's see how much traffic will that generate. Before I do, I wish to reset my capture, as I don't want this, as I want to see exactly how many packets will be recorded. So let me just find it. Yep, there we go. And I'm gonna pass -O, capital O, press enter. Here we go. It's initializing the scan, and you can see that there are packets already streaming in. It says 57, 50, almost 60 there. We'll see how much it will be, how much packets will generate in total. So not that, it's still going on. It's still going on. It stopped. And this is not good either. So it says almost 1600 packets. This is more than our previous scan, but this is something that you would need to do from time to time on your network as a pen tester, as a network admin, to figure out what is going on, what system is being used on the other side if you can't physically go over there or something of a kind. But as a pen tester, this is not good. It's 1600 packets, and again, you are bound to be detected. But these are just some basic options that you can pass. In the follow-up tutorial, I will explain in great detail how you can conduct stealth scans, and you will see how Wireshark, when it monitors the traffic, there will be a significant reduction of the amount of packets transmitted. In any case, I bid you farewell, and I hope that you've enjoyed the tutorial.